So we are working on solving linear inequality, and in the last video we learned all the processes involved to do so. In this video we're just going to be working through a few examples. So let's review real quick how to solve linear inequality. And the trick is we solve it just like an equation with one major exception. Anytime we multiply or divide by a negative, then we must flip the inequality sign. So if we have a less than, then we flip it to a greater than. And if we have a greater than, then we flip it to a less than. Same thing, less than equal to flips to greater than equal to, and vice versa. Okay, so let's see our second example here. Notice I have it listed twice because there's actually two different ways you can go about solving it, and of course either way is going to give you the same answer. But before I show you both ways, I suggest that you pause the video and see what you can do with this on your own. Okay, the first way I'm going to solve this is I'm going to move my variables to the left. And I do that by subtracting 4x from both sides. That cancels my 4x's out. And if I move my variables to the left, then I should counteract it by moving my constants to the right. And let me do that by adding 9 to both sides. On the left, 2x minus 4x gives me a negative 2x. On the right, 5 plus 9 gives me 14. And I did no multiplication or division whatsoever, so my inequality sign stays the same. Now, to get x by itself, my opposite operation is to divide by a negative 2. That cancels out my negatives and my 2, leaving me with x on the left. 14 divided by negative 2 gives me a negative 7 on the right. But since I did divide by a negative number, then my inequality sign flips. So this becomes x is greater than or equal to negative 7. And there is my solution to this problem. So I solved it the first way by moving my variables to the left. The disadvantage of it doing this way is that you have a negative that you have to worry about dividing by. Let me show you the alternate way to go about it. So instead of moving my variables to the left, I can move my variables to the right. And I do that by subtracting 2x from both sides. If I do that, then I move my constants to the left by subtracting 5. And that gives me a negative 14 on the left is less than or equal to a positive 2x on the right. To get rid of my 2, I divide by it. And that gives me x on the right, negative 7 on the left. I did not multiply or divide by a negative, so my inequality sign stays the same. So the advantage of this way is that you do not have to flip any inequalities because you did not multiply or divide by a negative. But the disadvantage of this way is this should not be your final answer because this is not in the correct order. We read from left to right, so we should also have our math notation from left to right. So in our final answer, we should always have the variable on the left-hand side of the inequality sign. So I need to rearrange this, and when I do so, it's like holding it up next to a mirror. I flip everything involved, meaning I actually do have to flip that inequality sign along the way to give me the same solution, x is greater than or equal to negative 7. So you see, either way we solve it, we of course get the same solution, and both ways have their advantages and disadvantages. The advantage to the first way is we don't have to rearrange it, but we do have to flip the inequality sign. The advantage of the second way is we don't have to deal with negatives, but we do have to rearrange it in the end. So when you're working this on your own, it's just a matter of personal preference. You get to decide which route you want to take. Now, it doesn't matter which route we take here, we still will have to answer these problems in any of the notations that your homework will ask for. So let's work through all of the notations. To graph it, let me start with my number line. I only put the number in question of -7. since my variable is on the left, then I get to shade this whatever way my inequality is pointing. This greater than is pointing to the right, so that means I will shade to the right of my value. This is greater than or equal to, so I have a bracket on the left. So my interval notation just mimics my graph, a open bracket, a -7, comma. The right arrow on my number line represents infinity, and infinities always have parentheses. And notice I put a parentheses here, but I do not put any parentheses up there. Okay, the last is set builder notation. It starts with the braces and x such that, and I fill in the blank with the same solution that I had back here. X is greater than or equal to -7. And of course, you should put that in with your variable on the left. So we have talked about all different notations for example 2. Okay, let's move on to example 3. Same type of problem, except for we're going to have to simplify it a little bit before we do the other operations. I suggest that you pause the video and see if you can get the correct answer to this problem. So my first step is to simplify both sides. I do that by distributing my 5 here, and I will do that by distributing my negative and my 3 there. That gives me 5x minus 10 is less than 9x minus 6x plus 12. Combining like terms on my right and copying everything else down, 5x minus 10 is less than 3x plus 12. I'm going to move my variables to the left by subtracting 3x from both sides, and move my constants to the right by adding 10 on both sides. That gives me a 2x is less than 22. To get rid of my 2, I divide by it. That is a positive number, so my inequality sign stays the same, and so my final answer is x is less than 11. Now let's do all the notations that go with it. On my graph, I put 11. Again, since my variable is on the left, I shade it the way this guy is pointing. Less than means we shade it to the left. I do not have an or equal to bar, which means I do not include 11, which means I have parentheses there. So my interval notation is negative infinity with a parenthesis up to 11 with a parenthesis. And my set builder notation starts with the braces, x such that, and I just fill in my blank with my final solution on the left. X is less than 11. So if I want to know what values I can substitute in for x in this problem here to make this a true equation, it's any number between negative infinity up to, but not including, 11. I have one more example of this. This one involves fractions in it. Again, I suggest that you pause the video and see if you can do it on your own. My strong suggestion is you solve it by using the magic trick that we've addressed multiple times before. So the first step in my magic trick is I need to find my least common denominator. Of course, I know the LCD between 3, 6, and 2 is going to be 6. So I multiply each one of these fractions by 6. When I do that, it should cancel all of my denominators out and should just leave me with no fractions. So on the left, 6 divided by 3 gives me 2, or a 2 times x plus 1, minus 6 divided by 6 entirely cancels out, but I do need to distribute this negative here through this 2x minus 4. So do not forget to distribute the negative. That is probably the biggest mistake I see in problems like this. And then greater than, since it was not a negative LCD. And on the right, 6 divided by 2 gives me 3. And so that leaves me with a negative 3 times x. Now let's simplify this here. I do that by distributing everything. Gives me a 2x plus 2 minus 2x plus 4 is greater than negative 3x. So when I simplify the left, my 2x's actually cancel out. No big deal, I just combine 2 and 4 to give me 6. So I have 6 is greater than negative 3x. Divide by negative 3 gives me negative 2 on the left, and I have my x isolated on the right. But since I did divide by a negative, that means my inequality sign flips. So I have negative 2 is less than x. But notice this is not in the right format. We should always have our variable on the left. So let me rearrange this. So my final solution here is x is greater than negative 2. Now, if you don't trust your work, you can always check it by plugging in a number that fits in this inequality. So you can check it by plugging in something larger than negative 2 and making sure that this ends up to be a true inequality like we expect it to. So my notation, I have negative 2 greater than it with a parenthesis because it's not equal to. Parenthesis negative 2 up to infinity, which is parenthesis, and my set builder notation is x such that x is greater than negative 2. And so we have finished all of the typical examples that you might see on your homework.